Namaste students, हमेशा खुश रहो बिटिया. I am JV'n Dr. Neeraj Dholia, Faculty of Agriculture and Veterinary Science, Jayoti Vidhyapeeth, Women's University, Jaipur. So students, we are here to discuss the topic centrifugation, and this comes under the subject upstream and downstream process. So this topic was incomplete in the previous lecture, so let's recap first and then we will go ahead. So centrifugation is a technique of separating the substances under the influence of the centrifugal force, and the sedimentation rate here plays an important role. So the particles whose density is higher than that of the solvent, they sediment fast. Okay, so this is the basis of the centrifugation. Now, on the basis of the speed, there are low speed centrifuges which have the maximum RPM is around 5000, and they operates at the room temperature, and they have the swinging bucket and the fixed angle type of the rotors. The high speed centrifuges are up to the 20,000 RPM, and because they are operating at the high speed, so the temperature control is necessary in that situation. So the biological samples generally are proceeded here, and the rotors in this type of the centrifuge are the fixed angle, swinging bucket, and the vertical rotors. So next is the ultra centrifuges. Ultra centrifuges are the most sophisticated type of the centrifuges. They operates at up to the 65,000 RPM, that is 1 lakh G, and the intense heat is generated due to the high speed. Thus, the spinning chambers must be refrigerated and kept at a high vacuum. So now let's talk about the types of the centrifugation. So principally, there are 4 types of centrifugations: the density gradient, the differential centrifugation, the rate zonal centrifugation, and the isopenic centrifugation. So what is the differential centrifugation? So it is the most common type of centrifugation, and it is generally used to isolate the fractions from the tissue homogeneous. So tissue such as the liver is homogenized, and it is also used to separate the organelles, cell organelles, and the subcellular particles on the basis of the sedimentation rate. So the homogenate is placed in a centrifuge, and it is spun at the constant centrifugal force, and the pallet is found there, and the other things are in the supernatant. Next is the density gradient centrifugation. So it is used to isolate the viruses, ribosomes, and the membranes. So density gradient is there. For that, we use the sucrose. So the increasing, uh, the sucrose density is created here, and the higher concentrations of the sucrose at the below, and the top of the tube, the lowest sucrose density is there. So from bottom to top, there is a constant gradient of the sucrose. So the particles of the similar matching densities will be settled in the similar densities of the sucrose. Okay, so they reach at the point where they find their density matches. So next is the rate zonal density gradient centrifugation. It is also known as the band or the gradient centrifugation. So in this technique, a density gradient is created in a test tube with sucrose and high density at the bottom. The sample of protein is placed on the top of the gradient and then centrifuged. So with centrifugation, the faster sedimenting particles in sample moved ahead to slower ones. The sample separated as zones in the gradient. So here the zones of gradient is prepared by the sucrose. Means there is no continuous scale is not there, but separated zones are there. So the molecules of the matching density will be settled in the matching density zone. So this is also that's why it is known also the as the zonal density gradient centrifugation. So next is the isopycnic centrifugation. So here the sample and the gradient forming solution is uh, put on the top of below preformed gradient or mixture in with the cell forming gradient. The solution of the biological samples with the cesium salt, cesium chloride is there, cesium salt is uniformly distributed in a centrifuge tube and rotated in a ultracentrifuge. So the under the influence of the centrifugal forces, the cesium salts redistribute to form a density gradient from top to bottom. So the first centrifugation will create the density gradient. Then particles move to point where their buoyancy density equals that part of gradient and form bands. So this is to say the sample molecules move to the region where their density equals the density of the gradient. So these are the various type of the centrifugations. Thank you. I hope you are satisfied with this digital session, and if you have any query, please write in the comment box. I will resolve your query. Thank you. And this session is powered by Digital Version 2, Jyoti Vidhyapeeth, Women's University, Jaipur.